What we are going to talk about is the idea of contract programming, also sometimes called design by contract. We're going to talk about how that can help make better, more secure software. And we're also going to talk about how we can make our code a little more boring, or at least a little less surprising. So it's a lot to cover in 30 minutes. I don't plan on being able to deep dive into all of that, but hopefully just give you guys at least the vocabulary, a little bit of an idea to be able to send you down the rabbit hole. So C++ or C developers in the room, pop quiz, okay? So let's say we have a function, we'll call it add1. It takes an integer, it returns an integer, and all it does is add 1 to it. So if you were paying attention during the last presentation, you'll know what the answer is. Anyone? Anyone? Negative 2 billion on most compilers. Yeah, so technically undefined for most, like GCC, you're going to get a very large negative number, right? So chances are, if you're not initiated into C or C++, that is probably surprising. It's also probably not what the original implementer intended for this function, right? And so what we're going to really be focusing on is how can we eliminate these kinds of surprises whenever we have folks using our software. So it can be kind of hard whenever you're presenting the second, third day of a conference, and a lot of people have usurped here. I don't need to define what APIs are. Several other people have done that better than I will. But what I would like to point out is the concept that an API decouples what the code can do from how it does it, right? So with that, the concept of abstraction comes up. So abstraction is really powerful, right? High-level languages allow you to abstract out the hardware details of the computer you're running on. Cloud service providers help you abstract out all of the hardware, right? So abstraction is really powerful. APIs help enable that. But the problem is, with abstraction comes some ambiguity and the idea of a mental model, right? So George Box, British statistician, he has a famous quote, "All models are wrong." The second part of that is some models are useful. For example, here we have the Mercator projection, right? So this is actually a fairly useful model. It helps us display a three-dimensional object on a two-dimensional plane. It's useful because we can talk about geography, we can point out the different countries, right? However, if this is your entire mental model of what the planet looks like, what happens whenever you try to travel from New York to Tokyo? You're going to take the long way around, right? However, if this is your entire model and you actually get on a plane from New York to Tokyo, you're going to be very confused whenever it takes off and starts heading northwest up and over Alaska and then down into Tokyo, right? So what we want to do as developers is help communicate our mental model of the code that we are providing to the users of that code. APIs are key to this because they are where our users interact with our code, right? So the previous presentation touched on the concept of contracts a little bit. The C++ study group 21, I think, has a pretty good definition of it, though. And they say a contract is a formal interface specification. A little bit more formally, we can think of a contract in terms of computer science as a set of conditions, preconditions that have to be true, some execution that happens that changes the state of our system, and some post condition that is true after that command executes. These three statements are called Hoare triples. Tony Hoare, British logician, kind of cooked up this branch of logic. So formally, that's what a contract is. So a set of preconditions that must be true, things that a function is going to do, and then a set of post conditions that we are going to assume to be true. Now, there are side effects, there are errors and exceptions, those are going to happen, but what we're trying to do with the idea of contract programming is to think about our pieces of code, our functions, in terms of what do we expect, what do we guarantee to be true at the end of this, and are there things that we are going to touch, the side effects, or are there invariants that we guarantee that we're not going to touch? Contracts have a property. They can either be narrow or they can be wide. So wide contracts have little or no preconditions. Within C++, we have the standard vector data structure, and it's got two pieces of its API, the size function and the at function. So size is a wide contract. If you have a vector, you can call size on that vector, and it's not going to throw an error. It's going to return whether you put objects into that vector or not, right? So this is an example of a wide contract. The at function, however, is a little bit narrower. So whenever you call at on a vector, you're going to be accessing an object at a particular index. However, the at function assumes that you actually have an object at that index. If you don't, it's going to throw an exception. So APIs are bad for security, right? Other presentations have, I think, done a pretty good job of convincing you of all the ways that they can be bad for your security, right? One of the major ones is incorrect usage of security functions. So a study in 2012 found over 1,000 Android apps using SSL incorrectly. They ended up leaking data. A follow-on study of those actually found out that by changing the API of the SSL library, it helped to improve the developer experience and made those errors that were happening a little bit more obvious, right? Other issues with APIs, right? Assumed or implied preconditions that aren't documented or aren't documented well, right? So an example of our first function, we are assuming that folks aren't going to pass int max and then trigger an integer overflow. And then also invariants that are not. So a function that either surreptitiously or accidentally modifies something, right? For example, if you have a REST API and you make a GET call, hopefully that's not changing things in the database that you're grabbing stuff from, right? And so a lot of people will say, well, I will just write better documentation, right? I will tell the users exactly how to use my functions, and that'll solve all the problems. Well, documentation might not help particular developers who are more oriented about just diving right into the code, right? I've done that before. I would assume a lot of you guys have. And then, as Stack Overflow has shown, developers are almost equally likely to read the documentation as they are to just go to Stack Overflow to learn how to use the service, right? So, just documentation is not quite enough. So, a couple of these CWEs were highlighted both on the last presentation and in others, but a couple of notes on these. So first off, on the side of implementing APIs, right? We've got CWE 1059, insufficient documentation, right? So that's the codified version of kind of what I just covered. But then also on the user side, or those that are consuming the APIs, right? Both of the CWEs that are listed, talk about not meeting the specification or having a poorly defined specification for your function, right? So first off, please don't try and read all of this code. It is not mine, so don't criticize it either. But the key here that we're going to talk about is heartbleed. So heartbleed, again, picking on SSL, was an issue where there was an buffer overflow that was caused by the heartbeat message in SSL. And the heartbeat message has both a payload, so some amount of data, and a payload length. Now, the heartbeat message assumes that your payload is actually the same length as your payload length. That would make sense, right? The issue was if you crafted a heartbeat message where the payload length was actually longer, down later in that function, there was a memcopy operation and bad things happened, right? So a couple of things that we can pull from this example, right? First off, the payload and payload length, for that to be a valid heartbeat message, probably should have been specified that someone should check that, right? We can debate whether that should be on construction of the message or here in the function that actually consumes the message, but somewhere along the line, we probably should have checked that, right? And then also, there's no checking that the actual input to this process heartbeat function was valid. So the actual fix was exactly that, to make sure that the payload length was actually the correct length of the payload that we were going to memcopy. So would a contract have solved this issue? Maybe, I don't know. I would guess though, if someone would have taken the time to at least document the idea that the payload length and the size of the payload should be the same, it might have been a little bit more obvious to whoever was using that struct to maybe check that, right? So now we're going to kind of talk about how we can start integrating this idea of contracts into our code bases. So I'm guessing most folks work on existing code bases. And as I've kind of shown so far throughout the presentation, one of the easiest ways is via comments, right? So just commenting your code, everyone's heard to do that, right? Since like programming 101, most people still don't do that. But with the idea of contracts in mind, we can actually structure our comments a little bit better. So we can specify our preconditions, our post conditions, and our invariants instead of just a one-liner that says this function does X, right? Additionally, if you're working in something like Python or JavaScript migrating to TypeScript, if your language supports it, gradual typing, introducing new or more descriptive types can also help here. So a lot of these pre and post conditions, we can actually wrap into the types that we're using within our language or within our products to help enforce those, right? For new projects, for anyone that gets to work on those, lucky, look at the ways that the tools that you're selecting at the start can help. So a couple of good ones, OpenAPI, helps define your API for web apps. There are also libraries in things like Java and preconditions in the Kotlin standard library that help support design by contracts. Rust also has a contracts crate, and I'll continue to plug C++. In the 26 version of the standard, they'll actually be getting formal support for the idea of contracts, maybe. Still to be decided. So the level of formality of contracts is kind of a continuum. So we've talked about comments, like those are good, right? A good starting point. Every language supports it, right? Documentation can also help. If you can auto-generate your docs or docs from comments, that's also good. As I said, Open API is also an excellent one, right? So you can give not only just documentation of your parameters, but example inputs and outputs. Again, really just trying to convey that mental model to your users, how they should be interacting with this API. But we can do better, right? So a couple of other methods that we have are very similar to techniques that you'll find in defensive programming. We can do runtime assertions. So as was mentioned in the last presentation, right? If we don't want a user to pass int max, we can just assert that the input matches our preconditions, right? So this is good, but if you really want to talk about shifting things left, right? If you're working in a compiled language, a lot of them have facilities to be able to assert things at compile time. So if you can prevent folks from using your API incorrectly at compile time, that won't even show up in your tests because it's never going to get compiled to be able to run in your test suite, right? So again, the idea of enforcing pre, post conditions and invariants within APIs is kind of a continuum. As was talked about earlier, this can scale all the way up to formal methods if your system really needs it, right? So couple of closing thoughts. I'm like the third of 4 presentations today about APIs, right? I don't think I need to make the case that they are everywhere and that they're going nowhere, right? Contract programming can help you, though, build better APIs as you think about what am I putting out there in terms of a mental model? What do I expect when someone is calling this function? What can I guarantee to that person whenever I return from my function? I think we've also quite thoroughly shown how APIs can be a security risk. And finally, that I think this is a fairly flexible way to start integrating that security into any of your applications. So with that, that is all I wanted to share. Free to take questions.
You know, so looking at this closing thoughts and some of the things you talked about with contract specification, it seems like that was much more formal with SOAP and security as well. So like, did we take a step backward going to REST API?
That's a really good question. So I don't know that we necessarily took a step back with REST APIs. I think most REST APIs are not actually RESTful. So, right? So if you actually go and read like the original dissertation, right? REST is really an architectural pattern. I think a lot of the HTTP endpoints that folks put out probably don't adhere to most of what's in REST as Roy Felding defined it. So hopefully that helps answer the question.
Well,
maybe just going to add to our conversations. It just seems that with SOAP, there's an enforcement of a schema that people have to adhere to. While with REST, it's a schema that's enforced at runtime. So like no, you won't know if it's right or wrong until you actually run it, and that's why you end up with all of this error checking with REST endpoints. If this property is in there, then actually do this. Otherwise, hey, throw an error. So it's just being aware, I guess, where the schema validation is being done, whether at runtime or when you're actually trying to make the code and do this contract testing that Alex has been talking about.